Yeah, thank you so much for the invitation. I'm glad to be here presenting my paper with Wanfang Wang and Oren Ziv, Entrepôt, Hub Scale, and Trade Costs. And just so I remember, how long do I have? An hour?
1 hour.
1 hour, perfect. So let's get started. Just to frame things, in general, trade is thought of kind of a bilateral arrangement between an exporting country and an importing country. We want to push back a little bit on this. There are lots of actual steps in the physical act of trade. Talk to anyone who's involved in importing and exporting. There's lots of things involved. You need to know about shipping, transshipment, distribution, all sorts of agents and potential third-party countries. Now, there's lots and lots to unpack here, and we're going to focus on one specific aspect. We're going to look at scale economies and these logistical activities resulting in what is generally called as an entrepôt. These are trading hubs where goods travel through from kind of third-party origins to third-party destinations. Now, these entrepôts are broadly going to be integral in our overall transportation network because they're going to help us facilitate international trade. So we're going to study these entrepôts, the networks they help form, and their impact on international trade. So to be a little more precise, let's focus on our overall research agenda here, which is what does the international transportation trade network actually look like? How do goods get from origins to destinations? And in particular, what are the roles of these entrepôts? We're going to be a little more precise in the definition in a second of these entrepôts. But with this, what do global trade networks look like after we account for this network? As in, is it important to account for this network of trading relationships when we think about welfare, gains from trade, and perhaps all the standard counterfactuals we run? And this is kind of reaching the point is, what is the implication? So for if we change kind of a fundamental tariff between countries, does the trade network change? Do the trade costs change? What happens? And are entrepôts important for this? So in this paper, we're going to characterize a global containerized trade network from two novel data sets. We're going to have customs data from the United States on shipment level of US imports, as well as port of call data on where container ships touch. And we're going to show that this trade network is indirect. It's highly concentrated via entrepôts. So think of a place like Singapore. Goods from India don't come directly from India to the United States. They go from India to Singapore, get put onto a new ship, and then come to the United States, which is going to resemble a hub and spoke network. Now we're going to build an estimated general equilibrium model, which is going to have optimal choices where exporters choose exactly what route their exports take and where these hubs or these entrepôts are going to endogenously emerge. Now, the nitty-gritty in the background is we're going to have a pretty nice standard Eden-Cordum Calendo-Pero or Carjan model in the background, and we're going to lay on top of it an endogenized trade network. Now, to estimate the scale elasticity, and this is going to be a very fundamental thing in our model, which is when you put more trade on a route, it turns out it gets cheaper to ship on that route. And we're going to develop a geography-based instrumental variable, building on some really, really old ideas to estimate a scale elasticity at the leg level in shipping costs. And just as a preview of the results, a 1% increase on traffic on a given leg is going to reduce trade costs by about 0.05%. Now that seems small, but think about how much trade from the US to China has increased over the last 30 years. When you add that all up, you're going to get relatively large increases in scale. And then we're going to evaluate a set of counterfactuals. Now, in our paper, we do 3 counterfactuals: hard Brexit, the opening of the Arctic Passage, as well as country level versus tariff versus transportation improvements. Now, we're not going to have time to go over all 3 of these, so I'll focus on 1 or 2 of them. But in general, what we find is when we allow for a scale elasticity to work through trade, the inclusion of scale economies can double or even triple welfare gains, because when you really increase trade over a route, that's going to decrease the trade cost and create a feedback loop. That feedback loop is going to work quite substantially to increase the gains from trade. And that kind of gets at kind of the network effect and our scale economy effect that we're looking at here. The network effect is going through these entrepôts. The scale economy is this endogenous fact that putting more ships on a route, putting more trade on a route is going to decrease costs.
Sharat, are you going to be able to distinguish between the scale economies that seem to come from like past investments versus actual scale economies?
So that's our next paper. And the answer is in this paper, no. We're going to just kind of take these macro level scale economies, which is going to be a combination of kind of internal firm scale economies on, you know, a single firm increasing the ship size, but it'll also be kind of competition effects. So more competition is going to decrease costs on a route, but also could be kind of port level infrastructure that we don't fully observe. So we're going to kind of reduce that and just kind of get a single scale elasticity here.
Okay, thanks.
So there's a background here. We're going to contribute in quite a few ways to a very large literature. We care about networks. There's a great literature there. There's also interesting literature on endogenous trade costs. But we're going to bring some micro data to discipline a lot of this. And then finally, there's another very interesting literature on agglomeration. And we're going to endogenously find a different type of agglomeration. Most of these agglomerations that you see are kind of at the city level, not on the trade network level. So let's jump right in to the data. We're going to focus on what we call containerized trade. This is kind of the big change in international trade over the last 40 years. Trade is now mostly conducted in these 40-foot long containers that account for 60% of all seaborne trade by value. They occur on set routes like buses with published schedules and minimal search costs, meaning if you want to get a good from China to Los Angeles, there's no searching you do. You know there's some 10 companies out there, you look up the companies, you look up the ship schedules, and you put your containers on these ships to get them from point A to point B. And in the background over the last 40 years, and this is not going to be directly model on our model, but it's a very important motivation. We've seen ship sizes go from what's on the left, which are these smaller ships, to ship sizes on the right. So on the left, we've got these ships that can haul about 200, 300 containers. On the right, we have ships that can now haul about 20,000 containers. Now, it turns out both of these ships require 14 people to operate. We looked this up. It's literally maybe 12 to 14 on the left-hand side and more like 14 to 16 on the right-hand side. In terms of fuel cost is not linear in ship size. It's actually kind of almost a square root relationship. So there's some true scale economies here. Now, is this all the scale economies that are going on? Perhaps not, but we want to just give you the idea that larger ships, more trade is going to be associated with lower unit costs. And we're going to try to get this overall relationship from our data. Now, in terms of the specific data, we're going to take two data sets that are quite nice. One is going to take every container ship. We're using actually data from 2014 here. So we're going to know every ship that carries containerized goods, where it sits in the water, and from that, we're going to actually infer how many containers are on it, as well as the latitude and the longitude of that ship at every moment in time. So we can follow the route of every ship and infer how much containers are on that ship at any given time. The second data set is not about the ship itself, but about the containers themselves. So for every container that enters the United States, we have something called a bill of lading. It's going to include all sorts of shipment information. It's effectively a passport of that container as it enters the United States. So we'll see this one container. We know this one container contains, let's say, cloth originally manufactured in India. So for that container, we will see it's manufactured in India. It was then put onto some ship in, let's say, the port of Chennai. We then see it move to the port of Singapore, moved onto a new ship. We see that new ship's name. We can then trace that new ship's route to the port of Los Angeles and then see that container being removed from that ship and being transshipped onto the United States. So this is, again, only for shipments that enter the United States. This is the bill of lading. And this has come through a Freedom of Information Act. So it's actually not covered by the traditional confidentiality that you need to have for US Census data, even though it's completely exactly what the US Census restricts. Now, we merge these two data sets together because we know what shipment comes onto the United States. We can trace the shipments. And so for this, we're left in 2014 with 106 million tons of goods and 15 million containers that enter the United States. To just visualize a little bit of what's going on here, because this data comes from the transponders on the ships, we actually know that about 90% of container ships have transponders. They visit 1,200 coastal ports. Now, I want to emphasize, when we say coastal, we include some inland seas here, but we don't include inland waterways on rivers. Minor issue, don't worry about that too much. We're looking at about 1,200 ports. We have about 4,000 to 5,000 container ships. Now, we know from registry data, there are about 5,500 container ships that haven't been scrapped on our time period. But if you look at the data, the container ships we're missing are almost all very, very small container ships. And we infer to think that these are very small container ships that only do inland waterways, such as the Great Lakes in the United States or like the Rhine Valley in Germany. So again, there are some caveats to this data, but this is the overall thing of the world here. The lines here infer kind of routes ships take. Now, again, we can project this onto water to show the water distance they do, and we actually do that. But this is just kind of the network representation of the map. You can kind of already see kind of a few kind of entrepot areas. The three big ones I like to point out are Panama, the Spanish ports near the Straits of Gibraltar, Egypt, and Singapore. So there are a lot of nitty gritty kind of going on in the data, and I've kind of gone through some of what's going on here. But I want to just point out that of these containers that enter the United States, we could match 90% of those containers through kind of a fuzzy process between where it started off in a foreign port and all the foreign ports it goes on container ships through to reach the United States. And so with this, we can also figure out things such as the weight of the container, how many containers form a bill of lading. So a lot of goods are shipped on like 10 containers. So we know the number of containers, we know the product, and we have the estimates of the value of what's on that container.
Can I ask a question about the bill of lading data?
Yeah, go ahead.
So you got it through the Freedom of Information Act?
Well, our data provider got it through FOA, yeah.
Okay, and okay, so who's the data provider?
It's now owned by S&P.
I see. And then
so when we started off, they were a small startup that gave it to us for $5,000. Now, if you ask them for it, they were charging $500,000 for our data.
What's this, the Panjiva or?
It was Panjiva originally.
Panjiva.
Yeah.
Oh, okay. So, and they handed it to you, it was clean. It wasn't like in a PDF like thing and then you had to scrape it or anything like that.
No, we had to scrape it off Panjiva. So we have about 2,000 lines of a smart scraping code that hit the Panjiva servers to scrape all the data off of it.
Okay.
We could talk about that more, but it's
yeah, no, I
cool
just
data.
wanted to know like exactly how this was all, because you know there are some of these companies out there, but do you see stuff like Walmart or no?
Yes, we see the name Walmart in our data. We are not using it on this paper. That is a future paper that we hope to write. So just to give an idea of what we're doing at the macro level, I think there's a lot of data here. We're just taking some cuts of the data. So one very interesting thing to look at is where do containers stop on average when they come from a country to the United States? So this is just looking at data that comes of containers that originate in the UAE. So let's look at stuff that comes from the UAE. It's kind of an entrepot in its own self, but goods from that flow around the world. So where do these containers stop in terms of ports before they hit the United States? And I want to first emphasize, if you add up all the percents here, they add to more than 100% because goods can stop in multiple ports or multiple countries. But the big ports, they stop in Karachi, they stop somewhere in Egypt, they stop somewhere in Spain before being put on new ships before coming to the United States, or being kind of staying on the same ship, but still coming to the United States. Very few trade from the UAE is direct. Lots of the goods stop in many, many ports before they come to the United States. Now,
Right. Sorry, but when they stop, do these ships collect more containers, or the container shifts? Is it what I'm trying to get at? Is it a meaningful stop, or is it just a stop for fuel and keep going?
So we do it both ways. So we're going to present any stop, including stops for fuel. If you go through the robustness exercises, we do the vast majority of our analysis where we also do where it switches ships. And the results go through. They're slightly different. I acknowledge the results are slightly different, but we have a problem where sometimes we're not 100% sure if they switch ships or not. And so we're just going to do any stop in the presentation we have now. But I'm open to, if a referee says you have to do is switching, we can do it, and 99% of the results go through in the same way. So with that, let me talk on a few stylized facts, because I find these stylized facts interesting because it's going to help us build up to a model. And so the first thing we want to kind of ask is, what does the International Trade Transportation Network look like? And what are the roles of Entrepôt in this network? And so, Anna, we're going to kind of get at some of these things because some of these facts look slightly different depending on what you count as a stop. But the overall trends are very similar. So
can I ask a little question here?
Go ahead.
Yes. So how is this data different from the one that you can obtain for this automatic identification system data, like the AIS?
So the AIS doesn't actually follow a single container. So AIS only tells you the ship name, where the ship is sitting in the water, so what the displacement of the ship is, and the time. It has really just those 3 data points. But you don't know if that ship, where the containers in that ship came from, right? So let's say we know that we can approximate, let's say there's 5,000 containers on the MSC Allegra from Karachi to Chennai. Now, we don't know if those containers on that ship originated in Karachi, or if those containers on the ship originated in the UAE, or if those containers on the ship originated in Hong Kong. So we need to tie that with our bill of lading, which is tied to the serial number of the container itself. So that's why we merge the 2 data sets together to follow the individual path, not of the ship, but of the container. Does that help?
Of the container, not the ship, I see.
And so that's, I think a lot of papers have written on just the AIS of the ships themselves. But there's a fundamental importance, which is, I'm not sure as a person who's looking at importing export, I care about the ship per se. Rather, I care more about the container, which has the value that we're considering and measuring. So again,
it has to be, Sharat, it has to be a container that ultimately is going to come into the United States, right? Because that's why you have the bill of lading.
Yeah, so again, we don't see the full network of every container, but for the stuff that enters the United States, where the US is the endpoint, we see the almost the entire route, subject to a couple of caveats that I've given earlier. So just one view. This is again doing by any stop. We can also do the transshipment stops, and it looks slightly different, but only 20% of the containers exported to the United States are direct. On average, there are 2 stops before they enter the United States. And this is kind of a histogram of that. Now, there are some countries that are direct. You can guess what most of those countries who are direct are. There's lots of Chinese shipments that are direct, a lot of Spanish shipments that are direct, and lots of Japanese shipments that are direct. But other than those kind of 3 places, even Chinese shipments, a lot of Chinese shipments will transship before they hit the United States. You can see this kind of distribution that's log normal in this shape.
Sharat, just for perspective, how important is container shipping versus bulk or I don't know what
Yeah,
what cars get shipped on.
yeah, so there are four types of global shipment. There's
Yeah.
containerized shipment, which is about 60 to 80%. 60 is a conservative number, 80% by value. Again, there's a difference between by weight and value. Then you have roll on, roll off, which are the cars, which is another 10 to 20%. Then you have break bulk. Break bulk is the largest by value, the lowest by value, but the highest by weight. What we're thinking is coal ore, iron ore, which is super heavy, but not worth much money because they're pure raw materials, right? Refined iron goes on containers, but the raw iron will go on a break bulk. So that's about 10, 20%. And then you have the last 10, 20%, which is going to be tanker. That's oil and compressed. And by tanker, I'm mixing both the super tankers as well as the compressed LNG type tankers, which are a slightly different type of tanker, but still important. So in terms of value, think about 65% of value this way.
And that's seaborne. What share is seaborne relative to the whole thing? Just to get a perspective.
Yeah. So we're gonna, in our empirical analysis, we're gonna take all goods that are containerizable, not just containerized, but also go on land borders. And we'll talk about how we account for that in our empirical analysis in a second. But if you look at that, it really depends on the route. So if you look at some coming from China to the United States, it's 100%, right? But if you look at what's coming from Canada to the United States, the estimates are we're looking at more like 15%.
Okay.
And I don't have a global number for you. I just have the US, China, and the US, Canada number off the top of my head.
Sure. Just I wanted to get some perspective of what part of the market we were talking about.
But Canada to US and China to the US are the same size markets. Okay. So that just tells you pretty much all you need to know. If you look at within Europe, you have the same type of issue, right? You have UK 100%, but you also have, Germany to Netherlands, which will be like 5%.
Sharat, you're thinking about only containers. If just to complete George's question, how about air?
Again, air. So there are goods that always go on air. There's like a very nice cutoff, and you look at it. This is actually some aggregate data. Certain HS categories go almost 100% by air. Certain HS categories go almost 100% by container, and certain HS categories go 100% by non-containerized transport. And we're gonna have a multi-sector model where different sectors have different shares. So the air sector, we're gonna say has trade costs, has all their things, but that's a different sector. And so when we do our full Eaton-Cordham style model, it'll be the Caliendo-Pero Eaton style Cordham model where certain sectors go by container and certain sectors don't go by container. Now, there is a slight margin of adjustment between container and air and non-container and container, but you look at the data, there just are not goods that fall in that valley because there's an order of magnitude cost difference between the three categories. So going by air, let's say is like $100 a pound. Containers will be $1 a pound. And going by non-containerized water will be $0.001 a pound. And so there are true order of magnitude differences. And so we're actually very comfortable saying that there's these different categories of goods, if that helps kind of the overall.
Sharat, I'm sorry. I missed
go ahead.
First 2 minutes of your presentation, but what was the reason you concentrate on the highest value?
These are not the highest value goods. These are actually the middle value of goods. The highest value goods either go by air or direct truck for land borders.
Sure, of course, but you are concentrating in the shipping, right? So we talk about shipping here. So
yes.
But what's the reason you concentrate on the higher values? What was the objective of that?
This is, so first of all, this is a paper on containerized travel where you have this hub and spoke network system. I actually have a very good set of references of papers that look at break bulk and non-containerized shipping, which is a very different world. We focus on this because this is an interesting thing that is the majority of value of seaborne shipping. And so, I mean, we might want to write another paper just on non-containerized shipping and mesh that for this. But we're going to hold those sectors as static with their own costs and not directly measure the shipping costs in those sectors, which you don't need to do when you do an EK style model. in hat algebra. Does that help?
That's fine, thank you.
Okay, so again, we already anticipated on a question. It's robust to alternative net measures of indirectness, such as the idea of transshipments, when goods get moved off one ship onto another, as opposed to just getting refueled. And this is really important because when ships are going indirect, it's not just a small change of distance. If you look at the distance by the lowest cost seaborne distance between two locations and the distance that goods come because they are put on and off ships, this is an increase of 30%. So ships are traveling effectively, containers are traveling 30% more on average than they would if all shipments were directly from origin to destination. And so just as think of this, doubling the number of stops a shipment makes, and because we actually have time-stamped locations of ships, is effectively increasing by 33% the amount of time traveled. And why isn't this one-to-one? Well, that's because there's a difference between time stop in port and time to get between ports. And so this is kind of our first stylized fact, which is the majority of containerized trade into the US is indirect, and it results in a very significant increase in shipping distance and time. Now, the second thing is now we want to tie all this to the idea of an entrepot. So we have this idea of entrepot, which is the central node in a hub and spoke network. Oh, yes, go ahead.
Sorry, maybe before, so maybe you already said that, but do you have data on like the cost of these shipments, or do you have a sense of whether, shipments that have a bigger number of stops are more expensive, or maybe they end up being cheaper because...
We're going to get to that. That is a lot of the purpose of the paper. So when we get to our estimation section,
I imagine you will estimate that, but maybe
we have an over-identification test from my co-author's forthcoming paper in AEJ that actually has a sample of our data, not all the data, but has a sample of our data. And we're going to show our recovered costs almost perfectly correlate to the actual published freight rates, if that helps kind of the idea of what's going on here.
Thank you.
So what is this hub and spoke network? And I realize I am going a lot slower than I expected, but you guys have great questions. So it's not your fault, it's more my fault. What we're going to do is make the scatter plot, which we have here. And each country is a dot on the scatter plot. On the x-axis is what percentage of trade from that country to the United States is accounted for that by that country. And the other axis is what percentage of traffic is accounted by shipments from that country. Now, if you're below the 45-degree line, that is a country that ships a lot to the United States, but isn't actually the last port a good is on before it comes to the United States. On countries above it are countries that may ship a lot to the United States, but disproportionately account for the last port before the goods come into the United States. So what are these countries on the top? These are the countries that we're going to call kind of entrepôts, at least to the United States. Some of the countries are very typical countries that actually don't produce that much. Egypt does not export much to the United States, but Egypt accounts for the last port where lots of goods come before they come to the United States. So lots of goods from the Gulf, from Eastern Africa, and from even parts of Asia will first flow through Egypt before they come to the United States, even though almost nothing actually is put onto Egyptian ships in Egypt, from Egypt itself. You also have Panama, you have Singapore, and interestingly enough, you have other examples such as Korea, which is an entrepot for a lot of goods coming from Asia, as well as Canada, which due to the kind of the funny quirks of the Jones Act is a very nice also stepping off point before the United States. On the bottom side, you have countries which are not entrepôts, but ship a lot to the United States. Taiwan, Germany, Italy. These aren't the last ports. Goods, Italian goods are not put onto a ship in Italy and directly come to the United States. No, they go to another country such as Spain before they're put onto a ship to the United States. Same is true with Germany. Many German goods some come from Bremerhaven, but most of them first go to Le Havre in France or Rotterdam before being put onto a ship and coming to the United States. So this is kind of our second stylized fact. Indirect shipping routes are going to be concentrated through these well-known entrepôts. These are the kind of the over the 45-degree line countries that we have here. And international trade is going to occur in this hub and spoke network where you have these goods going from Germany, Italy, Switzerland to a place such as like Rotterdam and then coming to the US, or being concentrated through Asian ports through either Singapore and Korea before coming to the United States. Then you have some ports that are kind of on the 45-degree line where both are common. Hong Kong/China is a very good example of this. Lots of goods may be entrepot there, but lots of goods also do originate in these areas. Now, we want to give a little bit of micro evidence of what's going on here. Why do we think that scale is one of these things? And we're just going to focus on one symptom. Now, we're not going to say this is the only mechanism. I think George had kind of a premonition of what's going to go happen here. You know, do we know this is all competition, or do we know all this is scale? And we're just going to look at one, which is contained ship sizes. And from the mechanical kind of shipping literature, there's a well-documented engineering relationship between unit shipping costs in terms of fuel and in terms of manpower and capital costs versus ship size. Now, there are other factors here, such as competition and entry on these popular routes, and they're going to work in the same manner as container ship sizes in terms of costs. So what we have here is, again, looking at these goods coming to the United States. And we're going to look on what is the ship size of a good coming from the United States versus what country it's coming in from. And so in circle is going to be all the countries that at least have at least one direct shipping route to the United States. Now, keep in mind, many countries around the world don't even have direct shipping routes to the United States. And in general, for these direct shipping routes, there's I want to say almost a perfect relationship between average ship size and the total amount of imports from that country. And these are for direct shipping relationships. So from places like China and Hong Kong, they come on very large ships, and we're importing quite a bit from those countries. But there's also a fringe of countries which are on the bottom. These are countries that don't directly ship to the United States. But some of them are coming on very, very large ships. So there's this data point on the bottom right-hand corner. I'm not sure I can write on this, and I apologize. So on the very bottom right-hand corner, there's a country dot there. That country dot is, I think, Laos. So nothing from Laos directly comes to the United States because it's a landlocked international country. It first must go through some other port, most likely going onto a ship before coming to either Hong Kong or China, before being put on one of those super tankers. And then it comes to the United States on a very, very large ship. And so what we see is a fringe of countries that ship directly to the United States. And there's a good relationship between ship size and the total amount of imports. But then there are kind of these free rider countries that are kind of taking advantage of nearby larger countries being put onto another ship before coming to the United States. This is kind of where we see both scale economies as well as the hub and spoke network show up. And so this is just kind of emphasizing this is not the only possible microfounded mechanism that's going on here, but goods from and through entrepôts are going to be loaded onto these larger ships before coming to the United States. So we've got a bunch of stylized facts and a bunch of micro support for scale. And I want to emphasize our scale micro support is not the only possible mechanism. And I want to emphasize this is not an IO paper. I know I do write IO papers sometimes. So we're not going to directly model the underlying mechanism that's going to generate the scale. Rather, we're just going to recover the overall scale relationship that the data implies. So let's go quickly through the model.
Sorry.
Yes.
Quick. So are you going to take into account like the patterns of exporting in recovering these things?
Yes.
Because you could imagine that, if you're exporting a lot from, say, the West Coast that's but maybe the imports are coming maybe from countries that are closer to the East Coast. Maybe that's going to put pressure to have ships on the other side. So that's, I don't know how that's going to show up in your estimates, or if you looked at this. But
Yes.
yeah.
Yes. So we won't do 100% of what I think is going to completely satisfy you, but we are going to account for all sorts of things such as trade imbalances. So in the background, I want to emphasize my co-author has a paper forthcoming in AEJ that talks about kind of what if there's more trade coming from one direction versus another direction, and imbalanced trade. That's all going to be in our model. Some of it will be in our residual and won't be amenable to the counterfactual, but it will be in the residual.
Yeah, I was
That will
wondering maybe it shows
directly
up in this scale parameter, or this, some of these scale effects. But yeah, I mean, I'll see what you,
Yeah, so it will be in the scale effect, but some of it will also be in the residual effect. So how much we're picking up in the scale effect, we might be attenuated. I'll be honest.
Thank you.
So what is going to be the point of our model? Our point of the model is going to be to understand how the trade network that we see in the data is going to rationalize the observed indirectness. And we're going to start off with two global sets of observables. One is on every leg between every two countries, we will see the amount of container traffic there is. Additionally, between every two countries, we will not only see the amount of container traffic between those two countries, but the overall trade volumes between those two countries. And so what we're going to do is embed these two pieces of information into an overall Ricardian model. Now, when we say the Ricardian model is mostly about trade shares, about trade volumes. And there are going to be some sort of trade costs that are going to rationalize that. We're going to endogenize those trade costs in that Ricardian setup, following a relatively new but very interesting literature, which will include multilateral resistance, the standard non-transportation trade costs, such as kind of tariffs, think of a Cayendo-Pero type model, as well as multiple industries, each with their individual trade, tariff, and production costs.
Sharat, I have a quick question. You say the container traffic and trade volumes, you said overall. You talked about the data before is all terminating in the US.
Mm-hmm.
So does this mean you have data on shipments that terminate elsewhere?
Yeah, so I want to emphasize we're going to talk about the container traffic. So there's a difference between again, units of observation we have. So for between any two ports, we know the total number of containers that go between those two ports. But we don't know necessarily what are the origin and the destination of those containers. Only for US distant containers do we know the full route. So what we're going to do is take a step back and just look at, we know all the total number of containers between those two ports, even though we don't necessarily know the final destination or the original origin of the containers on that ship. Think of this as traffic in the traditional sense of we know the traffic on the highway. And the trade volumes is we know exactly how many goods in the standard kind of BACI or the Comtrade trade data that there is.
Sharat, in those data, you know the number of containers and not their value, or both the value and number of containers?
We actually only know value. Sorry, well, we're not even know value, we only know volume. We have in the back of our mind a model where value and number of containers are isomorphic. So there's a linear relationship between the two to back out value. I mean, there's no other way we can kind of make progress on that. We do some back of the envelope calculations that seems to show that that's correct.
Well, there is to some extent, because in the UN Comtrade, you do observe unit prices by volume for most goods. And so you can adjust the value using those kind of country fixed effects for
yes, but there's that country fixed effect that we're not 100% how to use on this the leg, because again, on a ship that goes from, let's say, Panama to the United States, it's not just goods coming from Panama to the United States. There are goods being put on first from Argentina and goods from Australia that are being put on. So that fixed effect type of adjustment doesn't perfectly work. So again, that's why I said we do some overall checks on that, but we have to have this background assumption to make progress. So what we do is we take these two pieces of data and we embed it into a pretty standard recursion model. And I'm going to be a little quick on the step, but essentially prices are going to be a function of three things. They're going to be a function of underlying productivity. They're going to be a function of underlying bilateral non-transportation trade costs, such as tariffs or some sort of regulations, as well as bilateral trade costs between two countries. Now, what are these transportation costs? These transportation costs are a multiplicative set of individual leg level transportation costs. So just to focus here, we have a transport cost between I to J that follows some sort of route R. Now, there are N to the N effectual potential routes in the world, but all of those routes are going to just be the composite of all the leg level routes. So there could be a route between two countries that has 20 stops. Well, you're just going to add up all those stops between the countries to get the overall cost of following that route. And just to quickly visualize, we can get goods from I to J over many things. You can go directly from I to J. You can go kind of this route from I to K to L, then to J, which will then be a multiplicative relationship there, as well as you can go through this lower route. Now, again, we want to emphasize, we're going to endogenize this by saying all of these routes are going to be a function of how much containers follow that route. And therefore, a wider route means more containers are going through it, and it's going to reduce the cost. It's going to be an inverse trade cost. And we can add up all of this together. If we make some kind of Frisé style assumptions, which I'm not going to spend much time on, and which is formalized by Alan Orkalakis in a forthcoming paper in Review of Economic Studies, we can then say that all these goods, we can say exactly, we know what share of paths any goods between two countries will take. So if we know the underlying trade costs, we can generalize this using the lovely Frisé math that Sam helped me learn 10 years ago, and realize not only do we know the shares of goods in the United States that originate in China, we actually know not only the shares of goods that originate in China, but the share of goods that originate in China that first transshipped through, let's say, Hong Kong, or transshipped through Tokyo, or transshipped through Korea, as a function of not only the underlying trade costs in China, but also the different leg costs between all the different routes around the world. So I have 15 minutes left. So I'm going to jump a little bit through and just go directly to kind of what we're estimating here. We're estimating effectively two things: a scale level elasticity, which is what is the effect of the number of containers on a particular leg and the cost of shipping on that leg, as well as what is the fundamental underlying leg cost that is not affected by the scale elasticity, which is going to incorporate all sorts of things such as whether this bilateral fact that it's cheaper to go one way than the other way due to underlying trade balance issues and things such as that. So fundamentally, though, the big issue is we need to figure out if we can recover trade costs that rationalize the full global trade network, which is not crazy to do in the Eden Kortum style world. We also need to know, would those recovered trade costs was the effect of scale? And to do that, we're going to find an instrument. We need an instrument that's going to shift the amount of goods on any given leg that's uncorrelated with something else, such as maybe even trade flows on that leg. So what we're going to do is we're going to use a geography-based instrumental variable. So I'm going to start with just three countries: China, Singapore, and Australia. And goods can kind of flow on any of these two legs. But we want to get an instrument for an IV going from between Korea and the Netherlands. And we're going to try to figure out why goods may flow more on the China-Singapore leg than maybe the China-Australia leg. And that's only going to be because of geography. goods are going to more likely follow the Korea, China, Singapore, Netherlands route than the Korea, China, Australia, Netherlands route through just the simple fact of geography. The route that includes China to Singapore is going to be closer than any other potential other route, even if, there might be some fundamental shifters there. So we're going to use this intuition to say that demand for China to Singapore is going to be innately higher than the demand for, let's say, Korea to Netherlands or China to Australia, because it's going to be closer to a fundamentally very important trade route, which is Korea to Netherlands. But how do we know that Korea to Netherlands is very important? Well, that we're going to go back and use a historical geography shifter. We're going to use the population of every country in 1960, as well as the distances between countries in 1960, to figure out what routes are fundamentally more important to global shipping and what routes are fundamentally less important to global shipping if we only use the distribution of population around the world in 1960, as well as the distribution of shipping lanes that existed in terms of distance in 1960. And so what that does is it gives us a shifter to say what routes today should have more shipments versus what routes today should have fewer shipments. And so if we're doing that, we can then kind of do an instrumentation strategy. If we recover all the kind of the global trade to figure out what routes and what's the importance of scale, because this variable is going to be very relevant to scale, but not so relevant to kind of any of our conventional threats to identification here. And if you can come up with a reason for why this affects kind of our residual, please let me know and we can kind of think about it, knowing that we're also directly controlling for the distance between two countries. And we're calling this relative excess distance, tying to kind of an older literature that uses very similar instruments to figure out a bunch of relationships.
I have a quick question, Sharat. The model you're describing seems like it's rife with multiplicity problems.
Yes, there are multiple equilibrium. There are multiple equilibrium. That goes without saying. When I get to my counterfactual, so estimation today requires that we're in an equilibrium today. So that's not going to affect our estimation. It's going to be very first order for how you think about counterfactuals. And we're going to have a mechanism very specifically targeted to how we think about counterfactuals in this world, because the equilibrium today, first of all, I can't even tell you that our equilibrium today is the best equilibrium. There's no reason to think that today is even the best equilibrium, let alone to think of what is the next equilibrium. So we're going to have an iterative process to figure out a new equilibrium. That's going to take a stepwise process. We're going to do small perturbations by small perturbations to come to a unique new equilibrium that will be stable. But I can't even tell you that new equilibrium is the best global equilibrium. It's only true for small perturbations, small stepwise perturbations, but not large global jumps. And so we need to be very careful how we think about equilibria in our counterfactual analysis. And I completely agree with you, but that is not going to be an issue for our estimation of scale or estimation of today's trade routes, because we just have to assume that there is an equilibria. So there's a bunch of stuff we're doing here. I've got 10 minutes left, so I'm going to jump straight forward to first get to our scale elasticities. And so first of all, we do an estimation. We find a scale elasticity, which we have to first convert to a cost through an estimation of theta, which is kind of the dispersion from the EK Korda models, the Eden Korda models. And effectively, a 1% increase in traffic on a given trade route decreases trade costs by about 0.05%. We can use a bunch of over-identification tests here. I'm not going to go through all of this. Our targeted moments are almost perfect. Our untargeted moments are actually do quite well in our data. And we do more kind of overall estimates. This is just trade costs from Singapore. Light green means low trade costs. Dark blue means high trade costs. We're focusing again on the East Coast of the US for reasons that are more data related. But Singapore has the lowest trade costs with Hong Kong and Korea, unsurprisingly, and high trade costs with faraway countries. We can do all sorts of things here. We can also take our data, our model predicted estimates, and compare them to a mountain data. And I just want to spend a little bit of time on one of these, which is going back to Wanfang's paper, which is just, she actually has for a subset of our routes. Now we have many, many thousands of routes. She's only got 100-ish routes, but for those 100 routes, she actually has actual freight rates. So we can correlate our recovered freight rates just using the Eaton Corda machinery, as well as the Allen Arklakis machinery, to recover kind of what are the correlations. Now, it's not perfect. So a lot of this, any deviations from this, go into our residuals. But it's pretty good. We're looking at a correlation of 0.71. This is weighted. So the bottom left-hand corner is really kind of these high frequency routes as well, and you can kind of go down the entire path. But we do a pretty good job because in the background, and I haven't spent much time on this, but our residuals do include kind of two-way fixed effects on kind of, you know, one end might be the back haul, one end might be the front haul. There's a lot of stuff going on, but overall we do a pretty good job here as an over-identification check because none of this actual freight rate data is fed into our model. It's completely orthogonal. So with all of this, I'm going to skip on kind of this overall estimate of trade routes, but we have a very tight fit between our estimated trade routes on a leg level, but also on a global level, and kind of what's going on in terms of where do shipments go. So even though we're not directly targeting the share of shipments from the US to China that go between China and Korea, but we have that data, we can actually measure the two, and we find a very, very tight correlation there. It's almost perfectly correlated, that data. So with all of this data, what is important? Well, we actually want to do counterfactuals. And so with my last 6 minutes, I'm going to talk about a couple of our counterfactuals here. So we're going to do our counterfactuals by very carefully thinking about what's going on in a Caliendo-Pero model, which has three sectors. We have containerized trade, we have non-containerized trade, and we have non-traded goods, as well as full IO linkages around the world. And for the containerized trade, I haven't spent any time on this. We account for the fact that where there are land borders, not all containerized trade has to go over the ocean. It can divert to either rail or truck transportation. Again, I apologize for not going over that. If you have any questions after the talk, we can talk a little bit how we account for that fact. So we're going to run a bunch of counterfactuals, and we're going to do three types of counterfactuals. One is, what if we naively reduce bilateral trade costs between an origin country and a shipment country in the same way you see them do it in Caliendo-Pero, which is, let's say we just reduce tariffs, and let's not think that there's any scale, nor do we think of any trade network. We just have bilateral trading relationships. Then we're going to do another type of trade counterfactual, which is, what if we change trade costs, we not only reduce the trade costs between those two countries, but we let the rest of the world use that relationship. So for example, if trade costs are reduced between China and Singapore, because India gets goods from China through Singapore, India can then take advantage of some of those trade cost relationships between Singapore and China. And this is kind of taking account of the network, but we're not going to still allow scale. The last one is where this comes in. And this goes back to Jonathan's question about kind of multiplicity of equilibria. We have a full algorithm to show that even though we're not necessarily finding the unique global equilibrium, we're going to do, via small perturbations, we're going to find a unique new equilibrium if changes are not instantaneously. And so what we're going to see is, if you reduce costs between China and, let's say, Singapore, that has an effect that more trade will also want to follow that relationship. And you're going to get a kind of a feedback loop that kind of creates much more trade overall. Now, there's a full kind of counterfactual kind of algorithm that we use to get a unique counterfactual, even though it's not necessarily the global optimum. So with all those caveats, there are 3 counterfactuals, and I'm going to just do our last counterfactual. I think this is the most important, which is, does it matter? Is it more important to improve the actual mechanics of transportation versus is it more important to reduce tariffs and more classic non-tariff barriers between countries? So I'm going to end on that last counterfactual, even though I have all these cool maps for all the other counterfactuals, because I think this is very important. So this is looking at what happens if we do infrastructure level improvements in a place such as Singapore, Hong Kong, or any country. So if we do a 1% improvement in infrastructure in a particular country, such as automated ports, what are the most important ports around the world? So we're going to first just look at the overall world network with and without scale. And we're going to rank all the countries around the world by looking at how it changes on average the rest of the world relative to your own. The most important countries are classic entrepôts, Egypt and Singapore. The next country isn't actually a classic entrepôt, but it has a lot of entrepôt effects. So this is why Brexit is actually relatively dangerous, because a lot of goods go through English ports. And if there's congestion in English ports, regardless of the fact that even if they get the same, trade tariffs as they had before, congestion in British ports have a spillover effect around the world. The Irish suffer, the Icelandic suffer, a lot of Scandinavian countries suffer because a lot of trade is routed through the United Kingdom. You can kind of go through all these countries. Now, China and the United States are still important because they're just very large countries and they affect global welfare regardless of whether they're improving ports or they're improving logistics. So this is just looking at what happens when you improve transportation improvements, infrastructure improvements. And I just want to compare this to what are the most important countries around the world when you do the same set of improvements, but just on tariffs or trade costs that are not transportation improvements. And in that case, we're going to do both scale and no scale responses. And if you look at it, with the exception of Singapore, which we can talk about later offline, the most important countries are the more typical countries. These are kind of what you expect from Caliendo-Pero. And so this is kind of a Caliendo-Pero style analysis if you look at China, Germany, the US, Japan, France, and Italy. This is literally a ranking of how important countries are in world trade. So if you reduce tariffs, then you're just improving world trade in a very sensible manner. But even though we might be underestimated because there might be a scale feedback loop of what's going on, but this general spirit is correct. But if you're improving transportation infrastructure, you're going to want to target very, very different countries, such as Egypt and Singapore, rather than your own. And I want to emphasize, these are not the gains that accrue to Egypt or Singapore. These are the gains on overall world welfare, kind of on a weighted average. So with that, I'm just going to end right here. We do a lot. At least I think we do a lot. I spend a lot of time doing a lot of this. We study entrepôts, the networks they form, and their impact on international scale. I think, credibly can estimate a first order scale elasticity on if you increase trade, what happens to trade costs. But even without that, we can estimate on the kind of the global world map, if you change kind of underlying fundamentals, what happens to welfare. And we find that the trade network itself effectively doubles the importance of how much you care about world trade, but also the overall effect of including, I'm going to just say, scale economies is going to further triple the effect. And I want to emphasize the vast majority of the effect in terms of transportation improvement entirely comes from this concept of entrepôt and not kind of our traditional trade countries, such as the US and China, but rather kind of Singapore, Egypt, and Panama. And so with that, I want to thank you guys so much for all your great comments. And obviously, I'm open for more questions.
Okay, great. Thanks, Sharat. Yeah, lots of questions today. So let's give people a chance to continue asking. We'll leave the stream open. Go ahead and unmute and jump in, or you can raise your hand if you like.
Can I jump in fast because I have to go? Super interesting. I want to see the details, but I guess you guys have a paper so I can see the details. I was just reading, I think it was this morning, that in terms of the Brexit experiment,
Mhm.
that shipping volumes between Ireland and the UK are super down, so 65% down on the Holyhead to Ireland route, and then they've gone up like 208% on the France to Ireland route. I was just wondering whether is that an order of magnitude that sort of fits in with
Yes.
what your model would predict?
Yeah, so I don't have that exact route, but this is just looking at routes to the UK, what happens. The biggest effect actually isn't the route between London and Le Havre. The biggest effect is Dublin to, what's the port in the Thames? I keep forgetting, but
Holyhead.
yeah, to Holyhead. The biggest effect is actually ports in Ireland to ports in the UK. That's actually a bigger drop. And what ends up happening is the welfare effect is actually relatively muted, because most of that gets diverted to either Rotterdam or Le Havre. But the biggest drop is exactly what you see there. So that's a great thing. Maybe we should
You
put
can
that,
see it. It's like in the January data. You can
Yeah.
take a look and see whether your model already predicts that.
Yeah, so that is the very spirit of what we see. Like the biggest effects, actually, really enough, are not the UK effects, they're the Irish effects. Because Ireland right now currently is using the UK as a entrepot. Now, our model is actually very agnostic with this very small perturbations. It's not clear whether the best outgoing port is Rotterdam or if it's Le Havre in our data. So we have that, multiplicity of equilibria issue that Jonathan ends up, and it looks like Le Havre is the winner, not Rotterdam, but that's a slightly different, but still cool kind of thing that we can pick up on.
Thanks.
And thanks, Darren. I want to jump in, Sharat. If you go one slide before, we have the bar charts that you can kind of see.
So
Yes.
this is welfare. I didn't put in the bar chart with trade, because the trade has the diversion effect that Dorian kind of wanted. But this is the welfare effects, which is weirdly enough almost as high in Ireland as it is in the UK.
That's not at all weird.
Not weird, but yeah.
So I'll ask something. The kind of aggregate effects that you were talking about, these infrastructure investments, I was a little bit puzzled why you're emphasizing them being so big. On the one hand, there's, I've said this before, if you build a Suez Canal, it actually costs something. So you want to net that out. I usually say Panama Canal, but the other thing is it seems like there's something that's like missing, right? If there's like if it becomes a lot cheaper to go in this one way, it must be becoming much more expensive in another direction. I don't know if it's if we're kind of pushing more stuff through the international network, if like domestic networks become much more costly to use. And I don't know if that's captured in your model. I mean, I live next to the Erie Canal, and that's empty now. So is there something about something missing, like on networks within the country that kind of get crowded out?
So yeah, I'll be honest. When we do our counterfactuals, right, we hold the network within a country fixed. So in the DEK hat algebra, the tau II, right? So the trade cost from I to
that's
I,
what I was kind of thinking.
we're holding fixed, right? And so give me the data, and we can. If you give me a credible estimate on how that changes, I can put that back in, right? I just don't have a credible estimate on how tau II changes.
But I mean, I guess you're saying there's these economies of scale on these international networks.
But there's also diseconomies of scale in your home network then, right?
Yeah,
I'm not accounting for the fact that your home network is changing. In my analysis, I'm explicitly holding, because I don't actually measure tau II, I'm holding that fixed, right?
Yeah, I'm just wondering if you could do something like some back of the envelope that would allow you to sort of see, like, what would you need to kind of to sort of like undo some of the aggregate effects. It just seemed like you were kind of emphasizing something that was, not a fair comparison.
So one thing that we do is we don't do either economies of scale or diseconomies of scale in home or non-container routes.
Okay.
Right. So when we look at non-containerized trade between the US and Canada, or sorry, containerized trade between the US and Canada, because the vast majority of it goes on either a rail or truck, we're still not even putting scale effects on that. So there's no net effect on that. So this is just looking mostly at the global route, right? Because only 5 to 10% of trade from Canada to the US goes on seaborne things. So we're not taking account the full scale elasticity on the Canada to the US route, right? So there might be something else going on the trucking between US and Canada. It's not just between US and US, it's also US and Canada that's being in the data. And so, you know what, that's a good idea. I think what could help is a rough back of the envelope estimate on kind of how much internal scale or how much internal disk utility you need to offset our effects as a kind of like a back of the envelope kind of thing to frame it.
Yeah.
I think that would be helpful. I'm not sure we have credible estimates there. That's what, and so I think that it would just be more of a bounding exercise than anything else.
Right. Can I chip in one exercise? When I'm looking at this graph, it seems like the top countries are already Entrepôt, so they may be hitting some decreasing returns to scale. It's hard to imagine Singapore is going to take down even more shipping. It might be interesting to see which locations could potentially become Entrepôts and overtake them. So I remember reading that Djibouti a few years ago was trying to pose itself as the Singapore of the Middle East and take on that market.
So as you say that, I know at least one of my co-authors is grinning wildly because he's been pushing us to swap out one of our counterfactuals for that counterfactual. So I think it's I completely agree, and that's a great counterfactual we should run, and we should talk a little more exactly how we want to implement that type of counterfactual, because we need to think kind of, and this kind of actually goes back to a question that Jonathan had earlier, which is, what is the best global optimum kind of thing? And what our problem is, we have a current equilibrium, and we have a way of moving from our current equilibrium to new equilibriums, but it relies on all the changes being infinitesimally small. And so what happens is we take a current equilibrium and we perturb it a little bit, and we see what happens, and we keep perturbing it a little bit until we've kind of done a full perturbation that we've asked for to see what happens. The problem is a lot of the counterfactual you're asking for, and this is actually what Djibouti is doing, right? Is they're going to put in $20 billion to put in a new deep water port in where a deep water port doesn't exist, right? That's a big change. And we need to talk a little more deeply on the entire concept of global and local equilibriums in that, because this has multiplicity.
Right.
Right. And so if you have $1 billion, or sorry, let's say more like $50 billion, where should you put the new Suez Canal is an open question, or where should you put the new port of Le Havre, right? That's what you're asking. That's the big question. And I want to do that, but we're still struggling on just the pure computational like heavy lifting needed for that. That's like one of those like traveling salesman problem, but actually it's traveling salesman to the nth power. And there are smart ways of doing that. And I would love to talk to anyone who has some great ideas on how to do that. And like all the IO people have great ideas how to do that, but a lot of it, there are more trade-offs than they're willing to go on with. And we're trying to figure out what the right way of doing that is. But there is interest. We might want to spend a little more time going down that rabbit hole.
Sure. A question
Go ahead, Joe.
That's kind of related to what George was saying about the costs of, for example, these infrastructure investments. It seems like, as far as I can tell, I know you didn't have time to do the whole model in excruciating detail, but nobody earns any money from, say, being an Entrepôt, right? Singapore is not earning anything in your model from being this hub in this network, right? And I wonder whether you're missing anything from that.
Yeah.
Certainly you're probably missing something if you want to ask, what are the welfare gains for Singapore from something like this? But and more generally, there's nobody earning any money from, say, shipping, right? You don't have anybody running a shipping company and, for example, charging higher, earning more profits when they get to charge higher prices on a particular route or something like that. I wonder what
there is money in shipping going on, but it's an iceberg cost, meaning it's a fixed cost that's paid, but then sunk back into the water.
Yeah,
right. So it's not like interesting, right? We have it, but it's not interesting in terms of profits, right? That's why I said we're not talking about the IO of this, because there's a really interesting thing. And I acknowledge we're missing that because, there are all sorts of hub and spoke things with profits that you change in a subtle way. So we're missing that. That's one thing we're missing. The second thing we're missing is kind of like, can there be a tax from entrepreneurs, right?
Yeah, exactly.
And so what we're doing is we're only so there is a one benefit. Because of scale, Singapore being centrally located gets advantage of all those scales as imports and also as consumption. Yeah. Even though Singapore is not a big country, even if Singapore had zero production and was just a pure consumer, Singapore gets goods for about 30% cheaper than any other country in the world because it's an entrepot.
Yeah.
We have that benefit. We have that benefit, but we
fair enough.
The benefit of being the toll keeper. And so the toll keeper, right, can extract out some money before the goods are being because right now tariffs are only levied not on goods that transit at the port.
Yeah.
Goods that transit. So really, there's actually two borders. There's the port in our model. There's the port border and there's the country border. And they're actually separate borders.
Right.
Because with the exception of let's be honest, and the exception of two places in the world, all ports are free ports.
Okay.
So there's a logistic charge that's sunk into the water for offloading and onloading, but I'm calling that the logistics charge of you have to pay the workers, right? That I understand. That's a sunk. But then there's the cost of the fact that the country can endogenously change that price and take it for itself. That's charged in two places, right? That's charged by Egypt and it's charged by Panama.
Yeah.
That endogenized we have not done.
Okay.
And
that's what I mean. I know it's hard, but
yeah,
it's just
ideas on how to do that. Well, we're more than
I'll think about
that. But we are missing that, especially for Egypt. I acknowledge Egypt is a very large toll keeper in some sense, and we're saying that charge exists, but Egypt is charging the cost of that and dumping it into the water to pay wages, not to endogenously choose revenue and use that to do its own consumption. Right.
I mean, are they using it to dump it into the water and pay wages, or just service their bonds on their infrastructure, which is a totally different thing?
So in ours is not a dynamic model, so it's all paid out in labor at the end of the day, so it's dumped into wages in our model. I mean, this is kind of Sam and Jonathan's underlying fundamental model, right? There are costs that are paid. So we're not taking a stance on that. But the bonds is an interesting question, right? Because the question of the dynamics in these Mellets type models, we're not taking a good stance on that because we just fundamentally do not have a dynamic model.
Sharat, I have another question that's kind of two in one. I was struck by the 30% increase in routes to get from one place to the other so that you can stop at the entrepots. The main entrepots of the Suez Canal, Panama Canal, etc., it's not adding much. You have to go through there if you want to shorten the route. So one part of the question is, where is that 30%? Where's that big increase in the data? And two, the second part of the question is that we should care a lot about that, given how polluting ships are.
Yeah. So
can you maybe do a counterfactual or something that would reduce that, and what the cost of that would be, and what potential gains in the back of the envelope would be in terms of pollution?
So I ran this at lunch past, one of the environmental economists here, and Art Levinson, the first thing he said is, so how much more pollution do we have because of this? That's literally his first question, right? You're increasing pollution because these things are toxic and we know these are bunker fuel. It's the worst fuel. And so I've had people ask that question and it's that's a great question.
Yeah, but didn't you say that there's a lot of savings in fuel by the larger ships?
Yes, and that was my problem, right? So we need to figure out the scale response counteracted by the fuel response from the length. And that's why we don't do it, because it's really hard, because we haven't done that relationship. Because we're not, because the problem is ship choice is endogenous, and we're not explicitly modeling the ship size choice. So it's a great question, and there's a reason we're not doing it. And when we write our follow-up paper, which we're hopefully doing once all of us are off parental leave, which is going to be the internal IO of the ship size choice, which is kind of tying a little bit with Tom Holmes' work in a very different context. We'll hopefully do that. So we don't do that now. The second question is this 30% jump. We were a bit shocked at this, but the real issue is the reason why it's 30%. It's not just the Panama Canal is going through the Panama Canal. That exists. It's a lot of shipments are going the wrong way first. And when you go the wrong way, it's not just the increase in the distance, it's you're going the wrong way, so you're doubling. And just even a few shipments that go the wrong way a little bit completely increase your numbers. And so where do we see these wrong way shipments? You see a ton of this in Asia. You see stuff go from the Philippines to Singapore and then back to the US. And if the deviation from Singapore to the Philippines to the US is a little bit, the deviation from the Philippines to Singapore rather than Singapore to the Philippines is actually doubling or tripling or quadrupling, right? It's, we're literally steaming in the wrong direction. That's where you get the 30%. So even if it's just like 5% of shipments, if 5% of shipments travel the wrong way for like 20% of their shipment, you blow it all up. And that's what's driving the 33%. It's not just minor deviations, it's these wrong way deviations that you see. Keep in mind, half our data is literally stuff coming directly from Hong Kong, right? Like there's no deviation. They're just literally going the fastest route from Hong Kong to San Francisco or the fastest route from Hong Kong to LA. But there are enough stuff that have to go the wrong way to San Francisco or the wrong way to Hong Kong.
Why do you call it the wrong way?
Well, if you look at the least cost, so think of it on a straight line, right? The good, well, if you're going from, so think about a ship going from Singapore to Los Angeles. If it goes on the least cost route, that ship will pass by a couple miles of Manila by definition. But goods from Manila to the United States are not coming directly from Manila to the United States. They're going first from Manila to Singapore, and then the ship put onto a ship in Singapore, and then the ship in Singapore is going to pass Manila, but not stop in Manila before coming to Los Angeles.
Excuse me, I'm sorry. Did you list all these things because you pick up goods? Manila, from Manila doesn't go to the US because to Singapore because they need to pick up the goods from Singapore because they cannot travel with empty ships.
That's true, but
I just wanted to add also the choice of the distance of the ports. It is an endogenous decision, as you may have said.
Oh yeah, no, we're not disagreeing. Like in 19,
the fees count also. So they choose the port that is cheapest.
Yeah.
And also these shippers don't have no incentive to minimize the distance because the bunker price is so cheap.
I completely agree with all of this.
To reduce distances as long as the port is cheap, the fees, and the fuel is cheap.
Yeah. So I want to emphasize
it's not any optimality there, So.
All shippers are making the optimal choice given the set fees at every port and cost between any two ports. Okay, but the reason, and so one thing that we don't allow is we don't allow ports to endogenously choose their fees. That fees are going back into wages. It's just marginal cost in that. So we have to have that because otherwise, then there's an individual choice of every country to choose the optimal port fees. That's interesting. And I don't doubt that that's going on to at least some degree, but I'm not going to say that that's first order with the exception of Egypt and Panama, which I do acknowledge that there are some more issues with. So the other issue is bunker fuel prices are cheap. And that's kind of underlying driving our results. Otherwise, why else would you make that deviant choice, right? Bunker fuel prices don't include the pollution externality. And so our fundamental Alan Archilochus model, which I did not spend any time on, and I feel bad about it, is every shipper and every receiver is making an endogenous choice on the lowest cost route, knowing every leg's costs. Sometimes it'll include going the wrong way just because it is so cheap to ship around the world because bunker fuel prices are so cheap. And that is an optimal choice of the shipper to do so. And it's an endogenous optimal choice. And when we do counterfactuals, we are optimally rerouting each one of the shippers and what choices they make.
Yeah, I think I was just responding to the language. I think wrong way is just not the right language. If you can't say on the one hand optimal and then wrong way. So it just,
okay, so wrong way if you account for the pollution externality.
That's fine. That just seemed like that's like a completely different, paper, right?
Yeah. So again, there could be a really cool paper you could write, which is what's the optimal like carbon tax to, in the presence of this behavior, right?
But again, it's not obvious that shipping directly would be less polluting if you're doing it on a small ship.
Yeah. I agree. That's why it's an interesting paper.
Yeah.
Otherwise, there's a silly counterfactual, which is all shipping has to be direct, but then you're going to lose scale. You're going to lose the ability to go in these very big ships that are actually more fuel efficient, right? And so that's why it's a very interesting problem. What's the optimal carbon tax in the presence of these externalities?
Yeah, and then there may be some different equilibrium where Singapore has moved to Manila that may be much more efficient.
And that's another, so I think both of those they're not the same counterfactual, but they're very important counterfactuals that I don't think are trivial counterfactuals. I think they're very interesting, but I'm not even sure I have we have the computational tools. At least I don't think I have the computational tools right now without doing a little more work to figure out exactly how to do that.
Highly non-trivial.
Yeah. But those are all of these are really good questions. Gabriella, Anna, and Jonathan, and George, and even Joe.
Even Joe.
No, it's a great question. It's not an even Joe. I was looking at the list of people who I answered, and I was like, oh wait, I forgot one, and go back. No, they're all good questions. I think what happens is like when you open up kind of like these big black boxes, which we don't think about too much in this GE sense. Once you open it up, you open up a lot of good questions, and I think you've got all of the questions you've got are really good questions, but you kind of need to open up what we've started opening up as kind of some of the black box of scale economies, but you have to also include the kind of the GE framework. So a lot of this related literature of scale economies neglected a lot of the GE framework in the background that I think we've kind of put back in.
Can I ask one more question? You had this like nice slide where you showed that the trade costs were in your model were kind of related to the measured trade costs.
Yeah.
Trade costs. I thought that was interesting. I was just wondering to what extent I wouldn't expect them to actually line up as well as they did, because there's there's an element of time that these guys are saving, and it's really kind of there's some costs that are borne by the producer or the consumer by having like faster shipment. And so I wonder if you can kind of somehow add some, an additional control, which is kind of the speed of the shipment to sort of bring that even tighter, or make it worse or something like that.
Actually, Waterfog, did we try that at some point?
So George, just to clarify your question, are you thinking like in terms of instead of using cost, we like additionally like somehow map out like the time? The time,
yeah. I
mean, the time between these ports.
Yeah, you know how long it takes to kind of to go on stuff, and so you might have like it might be cheap, but it might take a long time, right? And that's going to cost the firm more. It might be expensive but fast, right? And there's always like this trade-off between time and trade costs.
Yeah, and that would definitely we can do for more port pairs than just the ones that I have for my paper.
Yeah,
we actually did this with time traveled on our introductory facts, so there's no reason we can't do this in this this
Yeah,
the
for
other
sure we
one,
can
right?
do that. Yeah.
Yeah.
Because it also, yeah, it's not just the distance, it's time traveled we have. Yeah. Because it turns out that the cost isn't actually the distance, it's actually the time.
Mhm.
The time
Right.
is much more sensitive than the cost.
Yep.
The
No,
cost
no,
aspect.
absolutely. So.
Yeah, this doesn't quite get at your direct question, George, but the second part of our sort of comparison in the model after just comparing direct costs is we're actually matching the data back to the US imports data, and there we do fairly well too. And so all we have to do, I think, is just add in time for that because we have exact time for the US data.
Yeah, so I didn't go over this slide at all. It's because it's a bit involved, but it's looking at kind of like model generated things and out of sample data that we have that we don't use to calibrate our model. And if these numbers are 1, it's just saying it fits perfectly. We don't fit perfectly, but we fit pretty darn close in kind of what's going on. And what our variances are, the standard errors are kind of our variance. Maybe that's time, and we're not picking up time correctly. And I think but we can include that as a control because we actually have that for every container that comes into the US. We know what data was loaded on in Chennai, and we know what data was unloaded in Los Angeles, right? It's literally the bill of lading. Though we do think, I think there is some error in that data. I think they're off by like 1 or 2 days for other reasons, but that's a small error, 1 or 2 days, considering most of these are month-long journeys.
There's some work by Georg Schauer who uses kind of like the time stuff. I don't know if you know that paper where they sort of show that like the uncertainty on when the ship arrives also seems to influence the trade flows.
Yeah, there's an econometric that's coming out or just came out by Brancaccio and co-authors that uses that uncertainty actually as an instrument.
Gotcha.
And they say, and that's to estimate like a search externality in a very different market. But like, some days you might just get a storm and your ship will go slow, and therefore your schedule will be off by a day. What happens to ship prices when fewer ships come in and stuff like that? Right. And so both Gorg and Brancaccio, Kalapokis, and I'm mispronouncing my Greek last names there. They have a very nice paper that looks at that too. But yeah, thank you guys. This was super helpful, especially the comments.
I'll stop recording then.